Okay, now let's see the first examples for sketching cubic functions where we have the function fx equals to bracket 2 minus x power 3 plus 1. So by referring to this function here given in the examples, it is not yet in the form that we want before we can apply the skill on graph sketching. So in step 1, the type of functions, we would like to have the form that we want, which is this one, the cubic in this form here. So we can get this form here by doing factorizations, where we factorize -1 from the x, and this will result -1 power of 3, and the bracket term here turn out become x minus 2 power of 3. And then simplify it, I have negative outside the bracket of power 3, and now you can see that if compared to the form that we want, we find out that a equals to -1, b equals to h equals to -2, k equals to 1. Then the next step we're going to do is that we're going to determine the shape of the graph. So in here we find out that the coefficient for x cubed we have here is negative. So for the case that I have coefficient of x cubed is negative, so the shape that I'm going to have is that this one. So next, we can quickly go to step 3 to determine the important point, which is this point here, the inflection point. So the next step, we have the special point, the inflection point here, and how we obtain the coordinates of this point by the x coordinates refer to the bracket part 2 minus x, we let it equal to 0, so we have x equals to 2. The y coordinate refer to the 1 there, so we have y equals to 1. So there goes the answer for our x and y coordinate for the inflection point to 1. And by the way, if you notice, just now actually we have convert into this form here, minus x minus 2 power of 3 plus 1. And in this calculation here, I just use back the original equations rather than this form here that just now we have convert, but yet the answer is still the same. You will find out the bracket parts here. X minus 2 equals 0, it still give me x equals to 2. The constant here, it still give me y equals to 1. Okay, go on. Now, once I have this inflection point here, the next thing what I want to do is that I go to step 4. I would like to have a rough sketch to know whether the x and y intercept exists or not. So, by having the coordinates 2, 1, the inflection point, and also identify the shape of the graph as follow. Now, we can see from the rough sketch here, we find out that the x and y intercept exists, and therefore calculations are needed to verify their locations. So to calculate y intercept, I can just have x equal to 0 to find out fx equals to 9, where the y intercept is 9. Whereas for x intercept here, in here we just try to use calculator if you want to have fast result, or you can just calculate manually if you have sufficient time. And you find out that for x-intercept, when fx equal to 0 or y equal to 0, we have x equals to 3, so the x-intercept is 3. And as a result now, with all these informations here, I should be able to have my answer for the graph as below. And remember, must make sure you do label the x, y axis, the origins, the name of the graph. In this case here is function f, so the graph name as f, the x and y intercept, and also our special point here, the inflection point. Okay. By the way, in the case that you want to determine the domain and range, by right just now in step 3, we already can have the answer that we can see. After you have determined the inflection point, we shall be able to see that the graph here, the domain, by the time you extend the graph, how far to the left and how far to the right our graph can go, you find out that it's all the way to the left is negative infinity, to the right is positive infinity. For range, how high and how low, it can go as low as y is negative infinity, as high as y is positive. And then back to the graph. Therefore now, this is a graph that I have. The domain and range is both infinity to infinity. So that goes the graph for example number 1 in cubic functions.